now, and it's recorded as video. So I will send it to you. You can review it.
Also, teacher, you will give us questions for the test from the worksheet.
It's questions, online questions. We will record it together right now, and then you can study it, and also the book. So all this you will study them for the final exam.
But teacher,
I have uploaded. Listen till the end. I have uploaded two sessions, yes, two videos about revision. It contains only questions, so you can watch these videos talking about these questions. And today, inshallah, another video. Okay, and the book. All these questions beside the book, you can use them for revision. Any questions else?
The questions there is just in one session 5 questions. We have just 15 questions, and the final quiz is the final exam is 13 questions.
30, not 13.
Yeah, 30.
Yes, from the book.
Teacher, what are the lessons for the final exam?
Topic 9, lesson 1, 2, 3, and part of lesson 4 until electric motors.
Okay.
Mr.
Yes.
Mr. What about
you will give us a practice quizzes?
Yes, I will give you some practice quizzes. I want to send it all on WhatsApp for you so you can practice it. Yes, Ammar?
What about the work? What about the project?
The project, I talked about it previously. You have to do magnetic levitation device like a train.
About the time.
Hmm?
The time.
After finishing, you can do this in the weekend, for example.
Because Mr. I order it and it will take some time. It will come Monday.
It's okay.
Can I make it like Monday and
yes.
It Thursday?
Yes, not Thursday. You send it directly after finishing it.
Yes.
Any other questions?
Mister, I send you the project in WhatsApp and you didn't reply.
I will see it. I'm so busy these days because of the exams. So later I can send it to you. Yes.
So we study for the test lesson 1, 2, and 3 and parts of lesson 4?
Yes.
Topic
Until
9.
electric motor. Yes, topic 9, yes.
Mr. Can you write it in the group?
And what?
In the group for WhatsApp.
I will upload this video. Contains this conversation. This conversation is recorded. You can listen to it. Okay. Let me start.
Mister, is the quiz on Sunday or Monday?
Sunday, 25th.
Monday.
You have a schedule on your WhatsApp group. So let me open a new one here for 7A and another one for 7B. And big one from 7A and another one from 7B, and that's how it would go. And let's take Ali Mit'ab al-Gannas. Ali Mit'ab al-Gannas. Ali. Okay, let's take one from 7B. الفهد. فهد السماعيل.
Yes, Mister.
الفهد, read this question. The first question, read it here.
Okay. Which one?
Awaina is constructing an electromagnet. This is the name of a girl, I think.
Awaina is construct the electromagnetic to demonstrate at the upcoming science fair. She is using wire, a nail, and a battery. How would this electromagnetic work? Okay, wire creates a loop between the nail and the tree.
Read all of it. Read in loud. Read all the choices in loud. We can hear you.
Okay. The wire loops the nail to the battery so that the current can flow directly to the nail, creating a magnet. The wire loops around the nail which becomes magnetic when the current flows from the battery through the wires. The wire loops around the nail and the battery, turning the entire system into a magnet.
So he wants you to describe how to make a magnet. This is a question. How would this electromagnet work? So he's just, you want you to choose or pick one of these sentences to describe how electromagnet.
B, Mr.
B,
voice is
read
loud.
it. Not my voice.
The
I'm good.
wire loop.
I think you're
The wire.
Mhm.
The wire loops the nail to the battery so that the current can flow directly into the nail, currently a magnet, creating a magnet.
Okay, let me remind you how to do the magnets, because I said electromagnet is something like this. Let me see if we have it here. Here, let me see the other one. This we have it here. It's not here. Let me add another one. Listen, to do a magnet, you do something like this. You have a nail. Let me draw a nail for you, a rectangular shape, something for magnet, something like this. And then you wrap a wire around it. So the wire will be something like this, and the wire will come out from here and down like this. So that's how you can create a magnet. I want you to choose a sentence that will describe something like this from the previous sentences. So then you will connect here a battery.
Oh yeah, I remember it now.
Okay, this is electromagnet. And the current will run through this from the positive end to the negative end. And we have a rule here. If you remember this rule, you have to put your fingers around it like this. So with the current, because the current I think will emerge, sorry, it's the opposite direction of this direction. You have to go with the current, the positive current. So it will go from here, from the back. We'll go back and until up here, down like this. So this is the direction of the current. And you can use your right hand, put your hand on it while your fingers will loop with the current in the wires, and your thumb will be directing to the north. So that is the north. If we apply this rule, that would be north, and that would be south. And the shape of electric field or magnetic field generated will be something like this. And that's the direction of it. Do it in green, for example. So this is the magnetic field generated. Again, you catch it with your hand, while your fingers must point to the direction of the electric current or loop with the direction, curl with the direction of the electric current, which is downward here. So you will grab it with your right hand like this. Your forefingers are curling downward with the current, and your thumb will be pointing to the direction, the north direction. That's how you can find the north direction. This is north and south, and that's called electromagnet. This one, this black rectangular shape, this is the nail. So we didn't mention that the current will go through the nail. It goes through the wires, which is looped around the nail. So I want you to choose the sentence here that answers this question. Which sentence here would answer this question?
Mr. Can I answer to me?
Wait,
D,
D,
Mr.
D, the
Mr.
wire loops around the nail and the battery. and the battery turning the entire system into a magnet. So this is the answer. Let me see the other choices because in them, the wire creates a loop between the nail and the battery. The wire creates a loop between the nail and the battery, turning the nail into a magnet when the current flows. The wire loops the nail to a battery, loops the nail to the battery, so the current can flow directly into a nail, creating a magnet. The wire loops around the nail, which becomes a magnet when the current flows from the battery through the wires. So it's not D. The answer is not D. D is wrong. طيب, Tamim 7A or 7B, Tamim? Tamim,
7A.
Okay, Tamim. What's the answer for this question?
Mr.
C.
The test will be how many questions?
30 questions. So the answer, yes, it's C, not D. The wire loops around the nail. That's describing what I have done here. Because the wires loops around the nail, and when the current flows through the wire, it will turn or it will generate magnetic field which will go through the nail, making the nail as a magnet. So the answer here is C. The wire loops around the nail. That's what we did, which becomes magnetic when the current flows from the battery through the wire. So this is the right description. All other descriptions do not describe the electromagnet. So the answer is C. Let's go to the next question. And let's pick some from 7B. Kazim. 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 Let me pick someone else. I want someone to answer from 7B. Sufyan. Sufyan. Muhammad Hashim. Muhammad Hashim. So go up. Abdurrahman Al-Hijji.
Mr. Kazim sent the
Yes.
chat. My mic is broken. He sent in the chat.
Kazim did that. Okay. Abdurrahman, can you
Yes,
answer
yes.
the question? Yes, read the question, please.
Amina is constructing an electromagnet to demonstrate at the upcoming science fair. She is using wire, a nail, and a battery. She is using identical materials to create 3 different electromagnets of varying strength. How can the same materials be used to create stronger electromagnets? Add more wire in between the battery and the nail so that more current can flow. B, place less wire in between the battery and the nail so that more current goes to the nail. C, add more loops of wire around the nail to increase the magnetic field. D, wrap fewer loops of wire around the nail to increase the magnetic field. C.
So add more loops of wire around the nail to increase the magnetic field. This one is right, yes. She's using identical materials to create the different electromagnet varying strengths. How can, this is the question, how can the same materials be used, the same materials, to create a stronger magnet? So if we come back here to the electromagnets, the strength of magnetic field generated depends on 2 things here. Number 1, the current flowing here, I, the strength of this current. If you increase the strength of the current, because we said previously that electromagnet can be the strength of the electromagnet can be affected by the current. Number 1.
Or the battery.
The current from the battery. The current comes from the batteries. So we are anchored to the current flowing through the wires. And this is number 1. Number 2 is the numbers of loops. If you increase the number of loops here, if you add more loops like this, you would increase the strength of the magnetic field. Okay, so you can increase the magnetic field strength, electromagnet, by 2 ways. Number 1, by increasing the current, and number 2, by increasing the number of loops. This one and this one. Okay. So the answer here, add more loops, answer C, add more loops of wire around the nail to increase the magnetic field. That would increase the strength of the magnetic field. Let's see this question. Pick someone from 7A. Abdurrahman al-Milham. Abdurrahman Abdullah al-Milham. Abdurrahman.
Yes, teacher.
Abdurrahman, read this question here.
Okay. Where's the teacher? I can't see the question.
It's
Now
in
I see
front of
it.
you.
Awahina is constructing an electromagnet to demonstrate at the upcoming science fair. She is using a wire, a nail, and a battery. Awahina also wants to make a chart to show what direction the magnetic field is following for each of her electromagnets. Describe how she would determine the direction of the magnetic field for the electromagnetic, including a description of a magnetic field appears around looped
wire. So she also wants to make a chart to show which direction the magnetic field is flowing. She wants to know the direction of magnetic field, okay, of her electromagnet. Describe how should we determine the direction of magnetic field for the electromagnet. This is one question. Describe how she would determine the direction of magnetic field. So I want you to answer this question, Abdurrahman. I've just answered, by the way, here. I said that we can determine the direction of magnetic field by using right-hand rule number 2, which is what?
Teacher, I think I was in the toilet when you demonstrated it.
Okay, let me use my hand. I want to see if my camera is working for you or not, so you can see me. So my hand, this is my hand. We use right-hand rule number 2 to indicate the direction of magnetic field. You will grab it in 2 ways. You can grab it like this or like this. It depends on the direction of magnetic field. It depends on the direction of, direction of the electric current. So I will grab the electromagnet with my right hand, while my forefingers will loop with the direction of electric current in the wires. So if it's going upward like this, my fingers will point upward if it's in front of me moving upward. But if the current is downward, I will curl it like this, downward. Let me show you the 2 examples here. This example, for example here, the current is flowing from the battery to the wires and go from the back and come. Here, my fingers will go with this in front of you, the part of the electromagnet that is in front of you, which is downward. So I will grab it like this. So my fingers, let me bring the camera. So my fingers, where is my hand? This is my hand. So my fingers will curl down like this in the direction of electric current, and my thumb will be pointing to the north. Again, my fingers curl down this in this direction, so they can show what? They can show the direction of electric current. The wrist or the thumb will point to the direction of north, direction of magnetic field, which is generated. So let's come back here. My fingers, this is my hand, and my fingers curling down with this direction of electric current, and my thumb will be pointing to the direction of north. So that's north, and that means that is the direction of magnetic field generated. So the rule that we will use it here, Abdurrahman, is called right-hand rule. I think that we have another one. Yes, we have a lot of these.
Teacher, today is there going to be a revision sheet?
This revision from the Savas learning, this one. This question is the revision sheet. I record the session and I'll load it to you. Okay?
Okay.
And so let's take this example too here. Here the current is moving also downward. I want one that the current is moving upward. I can draw one for you. Let me do it. Let me draw one for you like this. I'll draw it quickly. So the current, the wires will come like this from up and down, and then come down from here and up and up, not like this. Like this. So this is positive, negative, positive, negative. This is a battery, and this is the positive end of the battery, negative end, and the current will flow in that direction, upward, 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 upward. So how can I determine the direction of the magnetic field? I will grab it with my hand. That's important. I will grab it with my hand like this. My finger is pointing upward, and the thumb is directing to the north. This is north. So the direction here will be what? That would be north direction, and that would be south direction. And the magnetic field will flow from the north to the south, like this. So the answer for this question, Abdurrahman, is what rule we use it? We will use right-hand rule number 2. How can we use it? We will grab the electromagnet with our right hand, while our forefingers will curl with the direction of electric current, and then our thumb will be directing to the north direction, or the direction of north magnetic field. So this is how we can use it. Include description of how magnetic field appears around the loop. A description like this, it will start from the north direction to the south direction in curved paths, and will be straight inside here. So inside you can draw it like straight thing like this. And outside it curls or it moves in a curves. So let's go for the 4th question. And let me pick someone from 7B. محمد زكي بصبيح. محمد زكي بصبيح. محمد. محمد نطير. محمد علي رضا الهلال.
Mister, I'm here. محمد بصبيح.
Okay, Muhammad, read this question.
Clarence is comparing information about solenoids and solenoids and electromagnetic, and for a class project. Read each phrase and determine if it relates to either solenoid or electromagnet. Drag each phrase into the correct box.
So solenoid is only wire without the iron nail inside it. So they're so similar. The electromagnet, the one that generates electric field, solenoid is the same one like this one, but without the iron bar, only a solenoid, something like this. Something like this. Without the iron bar. And then you have it. But here we wrap it around an iron nail, for example, or iron bar. So we will answer the first one. Has ferromagnetic core. Is it electromagnet or solenoid?
Electromagnet.
Bravo, electromagnet.
Mister?
Yes.
Muhammad Lahlal told me that his mic he cannot respond.
Okay, no problem. Just 15. I didn't put in that. One from 7A. Ibrahim Rabia. Ibrahim. أحمد عبد الرزاق. أحمد العتيبي. أحمد العتيبي. إيش هو كله غربيين ولا إيه؟ أحمد عبد الله خالد الحسيني. عبد الله خالد الحسيني.
Yes, Mr.
Abdullah, read this. The second one. Created from stacked loop of wires. Created from a stacked loop of wires.
The first one,
Solenoid. Yes, first one, solenoid. So next one, it will be from 7B. Mahmoud Maher Abu Ghazal. Mahmoud Maher Abu Ghazal. Hussein Al-Gambar. Hussein Al-Gambar. How many one in the sessions? In the session, how many one? Session only 27. طيب محمود أبو غزالة نصير حسين القنبر برضه بدون تأنسر.
Mr. Kani Abdulaziz?
Yes, Abdulaziz, you can. Abdulaziz, answer this question. With this one.
Yes. If each has the same number of, it's Mr. Electromagnet.
Yes, if it has the same number and the tightness of loops, this is stronger because it has a core, has a magnetic core, has a ferromagnetic core. So the electromagnet is stronger. Used in MRI machines. Let me beg someone. Abdulaziz Badr. Abdulaziz Badr.
Hello,
Hello, Abdulaziz. Hello, Abdulaziz. The last one, used in MRI machines. Magnetic resonance imaging machines. This one that use it to image tumors, use it in medicine to take photographs. Which one is used? Solenoid or the electromagnet? Huh?
solenoid.
No, not solenoid. It's electromagnet. Used in magnetic resonance imaging machines, MRI. So it's electromagnet. 3 for electromagnet, and solenoid is only a wire. Solenoid is only the wire, but the one that we use it the most is the electromagnet. Putting an iron core just inside it will make it more beneficial in many aspects, from many aspects. So question 5. Ahmed Adil. Ahmed Adil.
Yes, Mr.
Read question 5, Ahmed.
Okay. Kira is creating a list of the possible ways that the strength of an electromagnet can be altered. Which of the following should Kira not add to her list?
Creating a list of possible that strength electromagnet can be altered.
Adding an insulator to the electromagnet.
Adding an insulator to the electromagnet. Yes, creating more wire loops. This is will changing the current, will change spacing out existing one. So all of this will affect the electromagnetic strength, except adding an insulator. It will not affect the strength of the electromagnet. So this is the answer. Let's exit this one. Thank you, Ahmed Adil, and go for lesson 5. Lesson 4, sorry. I think that we would answer only 1 or 2 questions here. Then I'll give you a quiz.
Mr. How many questions will the quiz be?
The exam, you mean?
No, the quiz you'll give us now. Will it come?
10 questions.
What?
10 questions. Only 10 questions.
Will it come maybe in the exam?
Faisal. 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 Khalid Al-Isa. Khalid Al-Isa. معن البشري.
Yes, Amir.
معن. Okay, معن. Read this question.
Johan sets up an experiment to test for the direction of a magnetic field. He performs his experiment twice. once with a straight piece of wire and once with a loop. As shown in the example below, both wires have a current running through them from a battery.
Yes. From a battery.
Joan wants to measure the current traveling through the straight wire in his experiment. He uses A as his tool. He places the wire in between two permanent magnets to measure the current created by the magnetic field.
So what is the name of the tool? He uses what as his tool to measure the current? So the question here, he wants us to measure the current traveling through the straight wire. Only we want to measure the current here. So what is the current? How can we measure it? The tool. It's called what? You know the tool? Meter or multimeter. The one that we use it to measure current, voltage, all of this is called ammeter or multimeter. So next one. We have here to know, we explained this one in a video, the direction of the magnetic field generated. So, man, you didn't answer the previous one. You can answer this one. The last question. Man. Maybe someone else.
Yes, here. I'm here.
So you didn't answer the previous one. Can you answer this one?
Juan? Okay, John sets up an experiment to test for the direction of a magnetic field. He performs his experiment twice, one with a straight piece of wire and once with a loop. As shown in the example below, both wires have a current running through them from a battery. Use the right-hand rule, in which direction will the single wire move, and in which direction will the loop rotate?
Yes. So here, as shown in the example, both wires have the current running through them from a battery. We have a current here. This is the direction of the current. And this is the direction of magnetic field from north to south. Use right-hand rule like this, right-hand, in which the direction will the single wire, this single wire, move. And in which direction will the loop rotate? The loop will rotate and single wire will move. So can you determine the direction of these? You will use right-hand rule like this. Your index finger will be pointing to the direction of the current, and the rest of your fingers, those three fingers, will be pointing to the direction of magnetic field, and the wire will be moving in the direction of your thumb. Can you see me here in the video? Let me show it to you. You will use your hand like this.
Yes.
Your index will be pointing to the direction of your three fingers pointing to the direction from north to south. Will be directing to the direction of what? Of the direction of a movement of the wire. So the single wire, you can do it like this. It will move in this direction. The camera is not working well. So this is the direction of the current. This is your three fingers, and the thumb is downward. So if we come here, the wire here will move downward. What about this one? Can you determine? So wire moves up, down, down. So one of these, A or B. We need to know the direction of movement of this rectangular here shape. So let me take a screenshot quickly and explain it to you. There is no time for the quiz. This is the last thing that I will give it to you.
Mr. Send the quizzes in the group.
I will send it in the group. Many quizzes, not only one. So this one, as I told you, will use the rule, and this one will move downward. So the direction here is downward. We need to know the direction. Remember that the direction here is in this direction. We only can use one, and this one will move and be like this. So I will work only in this direction. One of these, not to be confused, I will use this one only to indicate the direction of movement. This is the current here. Okay, so let me bring the camera. This is north and this is south. So this is the direction of the field. And this is the direction of the current here. Let me apply the rule here. Let me show that this is my hand. Okay. The current is in this direction. And the electric field, magnetic field in this direction, and the movement is downward. It's here. So this is the direction of rotation, which is clockwise with the clockwise مع عقارب الساعة يعني. It rotates, and we can say rotates to the left or rotates to the right. What we call this is the left, right, and this is left. So it will rotate to the right. The answer here, rotate to the right, because this is right, and this is what? Left. So it will rotate in this direction to the right, or you can say clockwise. مع عقارب الساعة. It will move clockwise, and this one will move downward. We have explained this in the previous lessons. Thank you guys for listening, and I will send quizzes on the WhatsApp group. Thank you, and have a nice day. Bye bye.